Alright guys, welcome back. Today we're doing geography in 8 minutes. Not all of geography, obviously. That would take like a semester and probably put everyone to sleep, including me. But we're hitting the stuff that actually matters. The core concepts that show up on every standardized test, every high school class, and honestly just makes you understand the world better.
Let's go!
Okay, so before we get into mountains and rivers and all that, how did Earth even form in the first place? About 4.6 billion years ago, the solar system was basically just a giant spinning cloud of gas and dust. Gravity pulled all that stuff together, and boom! The sun formed in the center. The leftover material started clumping into rocks. Those rocks collided and merged over millions of years, and eventually you get planets. Earth is one of them, and Earth just happened to land in the sweet spot. Close enough to the sun for liquid water, far enough to not get cooked. Scientists call it the habitable zone, which honestly sounds like something from a video game, but it's a real term. Early Earth was brutal though. The whole thing was basically molten. Heavier elements like iron sank to the center and formed the core. Lighter stuff floated up and became the mantle and crust. At some point, a Mars-sized object slammed into Earth, and the debris from that collision became the moon. That's the leading theory at least. Wild, right? So while we're on Earth's structure, let's talk about what's actually inside it. Earth has 4 main layers. The inner core is solid iron and nickel, incredibly hot, like 5,000 degrees Celsius. The outer core is liquid metal, and it's actually responsible for Earth's magnetic field, which protects us from getting fried by solar radiation. So yeah, pretty important. Then the mantle, which is mostly solid rock, but behaves like a very slow liquid over millions of years. It flows. And then the crust, which is the thin outermost layer we actually live on. The oceanic crust under the oceans is thinner and denser. The continental crust is thicker but lighter. Alright, this next part is genuinely cool, so stay with me. The crust isn't one solid shell. It's broken up into about a dozen major plates that are constantly moving, slowly, like a few centimeters per year. But over millions of years, that adds up big time. There are 3 main types of plate boundaries. Convergent boundaries. Plates collide. When 2 continental plates crash into each other, you get mountain ranges. The Himalayas formed this way when the Indian plate slammed into the Eurasian plate. Still happening today, by the way. Everest gets a tiny bit taller every year. Divergent boundaries. Plates pull apart. This creates rift valleys on land or mid-ocean ridges underwater. Alright, this next part is genuinely cool, so stay with me. The Mid-Atlantic Ridge is basically an underwater mountain chain where 2 plates are separating. New ocean floor is constantly being created there, and then transform boundaries. Plates slide horizontally past each other. The San Andreas Fault in California is the classic example. That's why California gets earthquakes all the time. If you live in California, you already know this personally. Volcanic activity is also connected to plate tectonics. Most volcanoes sit along plate boundaries, but there are exceptions, like Hawaii, which formed over a hotspot, basically a fixed plume of magma under the Pacific plate. As the plate moved over millions of years, it created a chain of islands. Older islands to the northwest, newer ones like the Big Island still forming over the hotspot right now. Okay, now the stuff you probably actually came here for. Mountains are the obvious one, formed by plate collisions, volcanic activity, or by rock layers being pushed upward by pressure from below. The Rockies, the Alps, the Andes, the Himalayas, all formed by tectonic forces. Plateaus are elevated flat areas. They can form when a region gets uplifted without folding, or when lava flows cover a large flat area and hardens. The Colorado Plateau in the American Southwest is a great example. The Grand Canyon was carved into it by the Colorado River over millions of years. That's erosion doing its thing. Valleys, formed by rivers cutting through rock over time, or by glaciers carving through mountains. You can actually tell which process formed a valley by its shape. V-shaped means river, U-shaped means glacier. Geologists actually use this, it's not just a textbook thing. Plains are flat, low-elevation land masses, often super fertile because rivers deposit sediment there. The Great Plains in the US, the Indo-Gangetic Plain in South Asia. Major agricultural regions, both of them. Deltas form where rivers meet the sea and drop their sediment. The Mississippi River Delta, the Nile Delta. Both iconic. Coastal areas near deltas tend to be some of the most densely populated on Earth because the soil is just that good. Deserts. People think deserts are just hot, sandy places, but that's only part of the story. A desert is defined by low precipitation, not temperature. Antarctica is technically the world's largest desert. Most deserts form around 30 degrees latitude north or south because of global air circulation patterns. Warm, moist air rises at the equator, cools, and drops rain in the tropics, then comes back down as dry air at 30 degrees. That's why you get the Sahara, Arabian Desert, Sonoran Desert all sitting around that same latitude band. We gotta talk about climate real quick too. The atmosphere has layers. Troposphere at the bottom. That's where weather happens, where we breathe. Then the stratosphere, which has the ozone layer that blocks UV radiation. Higher up, you get the mesosphere, thermosphere, exosphere. Increasingly thin, increasingly weird. Climate is the long-term average of weather in a region. It's shaped by latitude, elevation, proximity to oceans, and wind patterns. Tropical climates near the equator get tons of rainfall and stay warm year-round. Mediterranean climates have dry summers and mild, wet winters. You find this around the Mediterranean, obviously, but also California, parts of Chile, South Africa, southwestern Australia. Continental climates have huge temperature swings. Think the Midwest, brutally cold winters, hot summers. Ocean currents matter a lot too. The Gulf Stream carries warm water from the Gulf of Mexico northeast across the Atlantic. This is why Western Europe is way warmer than it should be for its latitude. London is at roughly the same latitude as parts of Canada, but London doesn't look like Saskatchewan. Rivers. Can't do geography without rivers. They shape the landscape, but they're also shaped by it. Watersheds are the areas that drain into a particular river system. The Amazon watershed covers about 7 million square kilometers, roughly 40% of South America. The Mississippi-Missouri system drains most of central United States. Groundwater is a huge deal that often gets ignored. Most of the world's accessible fresh water is actually underground in aquifers. The Ogallala Aquifer under the Great Plains supplies water to a massive chunk of US agriculture. It's being used way faster than it fills back up. Like, that's kind of a big deal and nobody really talks about it. Last thing I promise, erosion and deposition are constantly reshaping the surface. Erosion breaks rock and soil apart and moves it, done by water, wind, ice, even gravity. Deposition is when that material gets dropped somewhere else. Canyons, river deltas, sand dunes, floodplains, all products of these two processes working over long time scales. Glaciers are especially powerful. During ice ages, massive ice sheets covered large parts of North America and Europe and literally carved the landscape. The Great Lakes were formed by glacial activity. Most of the flat, fertile land in the northern US and Canada was shaped by glaciers retreating about 10,000 years ago. Anyway, that's a wrap. Geography done, brain full. Hit subscribe if you're new, and I'll catch you next time.